You're welcome to my class today, and we're going to be solving questions in logarithm. So I'm just going to basically explain, in a very simple way what logarithm is. Let me say I have log a to base b, and it is equal to c. So the logarithm of a to base b being equal to c is actually equal, or it actually means that a is equal to b raised to the power of c. That's what basically logarithm is all about. So whenever you see the logarithm of a number a to base b being equal to c, it is actually the same thing as a being equal to b raised to the power of c. So that was the reason why, if you had watched my previous video where we talked about indices, you would have seen that from this expression or definition, there's a close relationship between indices and logarithm. So straight up, I'm just going to highlight a few of the laws of logarithm. You'll see how it kind of relates very closely with indices. And of course, after this particular video, we're going to be dealing with some kind of a portion of logarithm that has to do with change of base. So in this particular video, I'm not going to be dealing with that, so I don't bring in too much complexities for you. So the first law of logarithm states that log of a number to the same base is actually equal to 1. The log of a number to that same number base is equal to 1. If you check it with the definition of logarithm I just gave to us right now, you can see that a is equal to a raised to the power of 1. That's the definition of logarithm, and it suits this law quite alright. Okay, so the second law of logarithm, you'll see the relationship between this law and the multiplication law of indices. It states that if I have log a to base b, and it is expressed this way, plus log of c to the same base b. Take note, the bases must be the same. This is automatically equal to log of a times c to base b. So whenever you see logarithm expanded as addition, it's actually coming from multiplication. If you remember the law of indices, which says that when the same bases are multiplied, what do you do to their powers? You add. So when logarithm is expanded as addition, it's actually coming from multiplication. Okay, so that means that if logarithm, the log of a to base b minus the log of c to base b, this is coming from division. So I have log of a over c to base b. You can see that indices and logarithm have some close relationship. So when you see the expansion of logarithm as subtraction, it's actually coming from the division of those two expressions. Alright, so I'll just talk about just one, the last one for today, and then in our next video we're going to be dealing with change of base. So if I have log of a raised to power b to base c, it is actually equal to this power b is actually going to be multiplying it behind it. So it's going to read as b log a to base c. If I have log of a raised to the power of b, if it's raised to the power of b, it means that I can bring b as an expression to become a coefficient, to become b log a to base c. So basically, these are just a few of the laws of logarithm. I'm just trying to highlight it to refresh your memory. So let's go into solving some logarithm questions. Very simple, very interesting. You don't have to be afraid when you come across such questions in the exam. It's simple. So let's take the first one. We have log of 25 to base 10 plus log of 8 to base 10 minus log of 2 to base 10. Now, sometimes in the examination, you might find out that they might not write the base number. When they do not write the base number, don't get uncomfortable. It's actually base 10. It's called the Napierian base. It's the natural base number 10. So when you see it in this form, it's actually base 10. But just for emphasis, sometimes they write the base number for you to see. So now, we have log 25 to base 10 plus log 8 to base 10 minus log 2 to base 10. Remember from the law of logarithm we just highlighted, we said when you see it expanded as addition, it is coming from multiplication. When you see it expanded as subtraction, it is coming from division. So we're just going to bring it back to its original state and then we'll simplify from there. So we have log of, this addition means 25 is multiplying 8. 25 times 8. This subtraction means that there's a division somewhere, all divided by 2. To what base? Common base, base 10. So it's been summarized, common base, base 10. So at this point we can simplify. So I have 2 go here, 1, 2 go here, 4. And so I have, what do I have left? I have log of 25 times 4, which is 100, to base 10. Wow. So you can see now that I'm gradually beginning to dissolve this question to become much simpler. 100 is a multiple of 10. 100 is a multiple of 10. So I can express 100 in the power of its base, which is log of 10 squared to base 10. So 100 is 10 raised to power 2. One of the laws of logarithm I just told us is that when a log of a number is raised to the power of any power, that power can come to become a coefficient to be multiplied behind it. So I'm going to have these 2 becoming 2 log 10 to base 10. So I now have 2 log 10 to base 10. And we said that when the log of a number to the same base is expressed, it is equal to 1. So the whole of log 10 to base 10 is actually 1. So what do I have? 2 times 1. Final answer, 2. You can see how simple that is. So let me just, go through it again. Log of 25 to base 10 plus log 8 to base 10 minus log 2 to base 10. I have log of 25 times 8 all over 2 to base 10, the common base. And then I simplify. 2 go here, 1, 2 go into 8, 4. 25 times 4 is log 100 to base 10. 100 is reduced to the power of its base, that is 10 squared. So I have 2 log 10 to base 10. Log 10 to base 10 is equal to 1. 2 times 1 is 2. Very simple. Okay, so let's take another question. So I have, this one is very interesting. Very, very interesting. So I have evaluate x. It says evaluate x if log 10 to base 10, where 10 is raised to the power of x, is equal to 3x plus 2. Evaluate x means find the value of x. X is a variable. Log of 10 raised to the power of x to base 10 is equal to 3x plus 2. The left hand side already simply makes us to understand that there is a law of logarithm applied here. So we have this power x is going to multiply to become a coefficient, applying the law of logarithm. So we have there x log 10 to base 10 equal to 3x plus 2. So you can see that log 10 to base 10, originally the whole of this is 1. So I'm going to have x into 1 equal to 3x plus 2. So I have x times 1 is x. So I have x equal 3x plus 2. I collect like terms across the equality sign. So I have 3x moving to the left hand side of the equality sign. I have x minus 3x equal to x minus 3x is minus 2x. So I have minus 2x equal to, so I'm going to be dividing both sides by the coefficient of x. The coefficient of x is minus 2. What you do to the left, you also do to the right because of the equality sign to make the equation to be balanced. So minus cancels minus, 2 cancels to 1. So I'm left with x being equal to minus is dividing plus minus 2 going to 2, 1. Final answer, x is equal to minus 1. So once you apply the law of logarithm here, x becomes a coefficient of the logarithm, x log 10 to base 10. Another law of logarithm, the log of a number to the same number as a base is equal to 1. That's how I got this one here. X times 1 is x. And then the rest is algebraic equation. This is an algebraic equation. You just collect like terms and solve for x, and x equal to minus 1. That's simple. So let's go to another question. So let's go. We have a question like this. These are likely exam questions. Log 125 to base 5 minus log 27 to base 3. And somebody is wondering, wow, this particular question, they don't have the same basis. This is base 5, this is base 3. How do I handle this? Very simple. It's not something you should be afraid about. Just look at the whole numbers. The whole number here is 125. Is a complete multiple of 5. While the whole number here is 27 is a multiple of 3. So you know you can reduce each of them to the power of their base. So we're going to start with the first one there. Log of 125. 125 is 5 raised to the power of 3. So I have log 5 raised to the power of 3 to base 5. Minus 27 is 3 raised to the power of 3. So I'm going to write log of 3 raised to the power of 3 to base 3. I have reduced each of them to the power of their bases. What does the law of logarithm say? It says when a number is raised to a power, the logarithm of the number is raised to the power, that number multiplies to become the coefficient of the log. So 3 is going to become the coefficient of log 5 to base 5 minus this other 3 will become the coefficient of log 3 to base 3. And we know that the log of a number to the same base is equal to 1. So 3 into 1 minus 3 into 1. Because log 5 base 5 is 1. Log 3 base 3 is also 1. 3 times 1 is 3 minus 3 times 1 is 3. Final answer, 3 minus 3 is 0. That's the answer. Very simple. If you go through the steps, you see that it's very simple. You just need to have the laws on your fingertips so that when the occasion arises, you apply as required and then you solve, and it's very, very simple. Okay, let's take another example of how we can handle laws of logarithm when we come across examination questions. Questions should not take you more than at most a minute, especially these kind of questions are OBJ questions. Sometimes they reflect in your theory. Just within a minute, at most 1 minute, 10 seconds, you're done. So we're going to just handle one more logarithm questions and we'll be done for this particular video. I have a question like this. Log of 25 raised to the power of x to base 5 minus log of 0.04 to base 5. And the student might look at a question like this and be wondering, how do I handle 0.04? Let me quickly put you through that. 0.04 is 4 over 100. I'm sure you know that you need to just look for a way to make that number resemble its base. The base is 5. So you should know almost immediately that there's a relationship between the whole number and the base. Almost always, except in a situation where you have to do change of base. In our next video, we'll be talking about how you change the base of a logarithmic expression. So let's stick to this based on the laws I iterated in this class. So I have 4 over 100, and you know 4 over 100 is 1 over 25. You can see 25 is a multiple of 5. In this case, it is inverted. So I'm just going to take it straight back to the original question. So 0.04 is 4 over 100. 4 over 100 is 1 over 25. So let's rewrite the question with that in mind. So I have log 25 to base 5. 25 is 5 raised to the power of 2. So that gives me log of 25, which is 5 squared, originally raised to the power of x to base 5, minus log of 0.04 is what? 1 over 25 to base 5. Alright. If you remember, in indices, we said power multiplies power. It can also be applied here. So I'm going to do this. Log of 5 raised to the power of 2x to base 5 minus 1 over 25. When it comes up, it assumes a negative index. So I'm going to have log of 25 raised to the power of minus 1 to base 5. I'm applying laws of indices as I'm also solving logarithm. That is why indices is very important. Now, this is a logarithm of a number raised to a power. That power becomes the coefficient of the logarithm. Remember the law of logarithm? So I have 2x log 5 to base 5 minus 25 is 5 squared. I'm reducing it to the power of its base. So I have minus log of 5 squared, originally raised to the power of minus 1 to base 5. Do you see that? Okay, so log 5 to base 5 is 1. So I have 2x into 1 minus the power here, 2 multiplies the power outside. I have log of 5 raised to the power of minus 2 to base 5. This power minus 2 will multiply and become a coefficient. Minus 2 will come and affect this minus here and become plus. So I have 2x times 1 is 2x. Minus 2 becomes the coefficient. There's an original minus here. That's the original minus. Then minus 2 becomes the coefficient. So I have minus 2 log 5 to base 5. As you can see, minus 2 becomes the coefficient. It comes to meet with this minus. It's going to be multiplying. So I have 2x minus times minus, that is a plus. 2 log 5 to base 5. Log 5 to base 5 is 1. So I have 2x plus 2 into 1. Final answer, 2x plus 2. I'd like you to look through it again, in case you have any confusion anywhere. 25 is 5 squared. This power 2 multiplies the x outside. It becomes 5 raised to the power of 2x to base 5. 0.04 is actually 4 over 100. As I explained earlier, you divide, you have 1 over 25. You invert 1 over 25, it gives you 25 raised to the power minus 1. 25 is 5 squared. The 2 inside multiplies the minus 1 outside. Power multiplies power. You have log of 5 raised to the power minus 2 to base 5. Meanwhile, log of 5 to base 5 here is 1. So 2x times 1 is 2x. And then you have minus 2 becoming the coefficient of this expression here. So you have 2x minus 2 log 5 to base 5. Log 5 to base 5 is 1. So you have minus times minus, it becomes plus. And then you have 2 log 5 to base 5, which is 1. And then you have 2x plus 2 into 1. Final answer, 2x plus 2. I hope you've enjoyed the lessons today, the explanations I showed us in the steps in solving logarithm. That's how far we can take for this particular video. In our next video, we'll learn more and apply the change of base law. Thank you very much.